Good morning, class. Today, we are going to have a new lesson on simplifying radical expression. So, what is a radical expression? This is the definition is a radical expression is a numerical expression or an algebraic expression that include a radical sign. You look at the radical sign. Let's have an example. You read this as square root of x squared plus 5. Another one, 10 times the fifth root of 32. Another definition of a radical expression is it can also have a fraction as expression. Example, we have here square root of 32 over 6. Or we have here square root of 3s squared divided by 27s. Now, there are three important pieces of information in any radical expression that are important to identify. These are the radical sign, the radicand, and the index. Take a look at the following radical expression. You read this as cube root of 27. This symbol is called the radical sign. You look how it is written. You have to remember that. Next, the numerical expression or the algebraic expression within the radical sign is called the radicand. In this case, the radicand is 27. And the number 3 there, you look how it is written, is called now the index. Okay, let's have to remember also the properties of radicals. You have to take note that you read this as the 8th root of x, or this could be written as x raised to 1 over a. Example, square root of x could be written as x raised to 1/2. Okay. The product property of radicals. So here, we have here the square root of x times. Take note of that. The dot there is implied that is multiplication. The square root of y there is equal to the square root of xy. We multiply x times y equals xy, wherein x should be greater than or equal to 0 and y also should be greater than or equal to 0. That is the product property. Now, the quotient property of radicals are, we have a square root of x divided by square root of y. Or that could be written as square root of x over y. Take note of that. Okay? Wherein x should be greater or equal to 0 and y also is greater or equal to 0. In the same way, we know that square root of x squared is equal to x. I repeat, square root of x squared is equal to x, wherein x should be greater or equal to 0. Okay, we are going to write exponential expressions in radical form. Let's have this example. How do we read this? This is 8 raised to 1/2. Number 2, 5 raised to 2/3. Number 3, 7 raised to 3/4. Number 4, 3 raised to 2/5 or 3 raised to 2/5. And number 5, 1 raised to 4/3 or 1 raised to 4/3. Okay, how shall we write 8 raised to 1/2? So in this manner, you look at this. 8 is the radicand, okay? The numerator that is 1 turned out to be the numerator. Turned out to be the exponent. I repeat, 1, which is the numerator, turned out to be the exponent. And the denominator 2 turned out to be the index. Or this could be written as square root of 8 raised to the first power, or this is equivalent to square root of 8. What happened to 2 and 1? Now, you have to remember the index. If the index is 2, no need to write there in the index as 2. Understood that is 2. And 1 here is the exponent. If 1 is the exponent, no need to write 1. Did you understand? So, 8 raised to 1/2 is equal to square root of 8. Okay, now let's have example number 2. 5 raised to 2/3. So 5 here is the, turned out to be the radicand. The 2 here, which is the numerator, turned out to be the exponent. And 3, the denominator, turns out to be the index. So, you read this as cube root of 5 raised to the second power. Or, it could be written this way. Cube root of 5 raised to the second power. You look how it is written. 3 is there. And 2 turned out to be the exponent. You look at that. Okay, let's have number 3. 7 raised to the 3/4. So 7 turned out to be the radicand. 4, the denominator, turned out to be the index. And 3, which is the numerator, turns out to be the exponent. Or this could be written as 4th root of 7, open and close, raised to the 3rd. Okay? Next, number 4. 3 raised to the 2/5. So, 3 turned out to be the radicand. The 2, which is the numerator, turned out to be the exponent. And the denominator 5 turned out to be the index. So, 5th root of 3 raised to the second power. Or, this could be written as 5th root of 3, open and close, raised to the second power. And the last one, 1 raised to the 4/3. So, 1 is the radicand. 4 here, the numerator, turns out to be the exponent. And 3, the denominator, turns out to be the index. Or this could be written as cube root of 1 raised to the 4th power. So that is how to write exponential expression in radical form. Okay, now the vice versa of that, writing radical expression in exponential form. So how do we read this? How do we read this again? For number 1, this is square root of 10. So 10 would be the base. What's the index here? It is understood to be 2 there. And since there is no exponent, that is considered to be 1 as the numerator. Next, third root of 5. Okay, that is 5. The radicand turned out to be the base. What's the exponent here? Understood to be 1. And 3 is the denominator. The index now turned out to be the denominator. Next, what about the square root of 7 raised to the third? That is equal to the radicand 7 to be the base. 3 here, which is the exponent, turned out to be the numerator. And 2 here is the index. Understood that the index is 2. So the denominator. Next, fourth root of 8 raised to the third. That could be written in exponential form. 8 to be the, what do you call this? The base. And 3 here, the exponent, turned out to be the numerator. And 4, which is the index, turned out to be the denominator. Next, for number 5, sixth root of 2 raised to the 5th power. So 2 now is the radicand, turned out to be the base. The exponent, which is 5, turned out to be the numerator. And the index now turned out to be the denominator. Did you understand it? Okay, we proceed. A radical expression is said to be in its simplest form if there are no perfect square root other than 1 in the radicand. I repeat, there is no perfect square factor. Perfect square factor. Look at that. Perfect square factor other than 1 in the radicand. Okay, let's have this example. How do we read this again? This is square root of 16x. So that could be written as square root of 16 times x. So what is square root of 16? That is 4. So we put it outside already. And the square root of x, since it could not be extracted anymore, will stay at the inside the radical sign, and it turned out to be the radicand. So how do we read this? That is 4 square root of x. So this is the simplified form of square root of 16x. Okay, next, there is no fraction in the radicand. Example, square root of 25 over 16x squared. So here, we could separate this way. Square root of 25 over square root of 16 times square root of x squared. Okay. What is square root of 25? We have there 5. What about square root of 16? That is 4. And square root of x squared, it's x. How? Since index here is 2. 2, isn't it? The exponent here is 2. And the x index is also understood to be 2. So 2 divided by 2, understood to be 1. So it turned out to be x. Okay? Next. It is also in the simplified form if there is no radicals that would appear in the denominator of a fraction. I repeat, there should be no radicals that would appear in the denominator of a fraction. Example, square root of 15 over 16. So here, we have to separate the square root of 15 over square root of 16. And we have there square root of 15. It's not perfect, so it would stay as it is. Square root of 15. Square root of 16 is 4. So this is the simplified form of square root of 15 over 16. Now, if the denominator is not a perfect square, what should we do? We could rationalize the denominator by multiplying an appropriate form of 1. Let's have this example. Square root of x over y. There. So, we could have there square root. We have to separate square root of x all over square root of y. Now, to rationalize this, what is our denominator? It is square root of 5. So we have to multiply it with square root of 5 over square root of 5. What is square root of 5 over y? It is the form of 1. We said that any number divided by itself is equal to 1, right? Square root of 5 divided by square root of y is 1. So we did not change the value of this expression, square root of x over square root of 5. So we continue. So square root of x times square root of y, we have there square root of xy. And then square root of y times square root of y is square root of y squared. We have to add the exponent. 1 plus 1 is 2. Correct. And so, square root of xy we have to rewrite as it is. And what is square root of y squared? It's y. I explained it a while back. 2 divided by the index, which is 2, is equal to 1. So it's already 1. So the simplified form of square root of x over y is equal to square root of x y over y. Okay. We now have to simplify radical expression. Let's have example number 1. Simplify square root of 45. Now, think of a number, one of the factor, as I said a while back, should be a perfect square. And what are the factors of 45? Wherein 1 is a perfect square. So we have there 9 times 5. Correct. 9 is a perfect square, which is also a factor of 5. And what is square root of 9? Of course, it is 3. And then square root of 5 will stay as a radicand. So we use the product property. Next, number 2 example. Square root of 12 over square root of 3. So we could use the quotient property. That would be 12 divided by 3. That is equal to 4. And what is the square root of 4? It's 2. Okay, that is example number 2. Let's have another example. Example number 3. Square root of 12, x raised to the second, y to the fourth. We could have it as, we factor 12. What are the factors of 12? That 1 is a perfect square, that is 4 times 3, right? And then times x squared times y to the fourth. So what is square root of 4? That is 2. So we have to write it outside the radical sign. Now 3 will stay inside. It turned out to be the radicand. What is the square root of x squared? 2 divided by 2 is 1. So we have there x raised to the first, or you need not write 1 there. And y to the fourth, 4 divided by 2 is 2. So y to the second. So our final answer, class, is 2xy raised to the second power square root of 3. That's now the simplified form of square root of 12x squared y to the fourth. And the fourth example, we have there square root of 25 over 3. So the solution, well, 25 over 3 cannot be divided exactly. So what shall we do then? So that is, that square root of 25 is 5, correct? And square root of 3 will stay as square root of 3. But remember, this is not yet in the simplified form since there is a radicand at the denominator. So what shall we do? Yes, we have to rationalize it. How again? What is our denominator? It's square root of 3. So we are to multiply it with square root of 3 times square root of 3. Since square root of 3 divided by square root of 3 is still equal to 1. So we do the multiplication now. 5 times square root of 3. We simply rewrite 5 and then square root of 3. Remember, we could not multiply 5 times 3 here. Since 5 is a whole number and square root of 3 is a radicand number. So we simply rewrite them side by side. That means 5 square root of 3. Now, square root of 3 times square root of 3, what's the answer? It is square root of 9. And what is now the square root of 9? It's 3. So we rewrite the numerator as 5 square root of 3 over square root of 3. So that is how to simplify radical expression. So next meeting, we are going to have the 4 fundamental operations in simplifying radical expression. That is addition, subtraction, multiplication, and division of radical expression. As of now, that's all for today. Bye!